we are going to see the programming with control instructions for finding ascending order, descending order, smallest number and greatest number, and programs using rotate instructions, hexadecimal code to ASCII and BCD code conversions. First, we are going to find the program to find ascending order, descending order, largest number and smallest number. And here we are going to see the assembly language program to find smallest, largest, arranging array in ascending order, arranging array in descending order using 8086 microprocessor kit. It is a 16-bit processor and a keyboard. And this is the algorithm. We have to load the array count, okay, number of several number of values in CL register, and we have to first get the two numbers and compare the numbers and exchange if the number is large, and get the third number and repeat the same process if it is larger, and exchange, okay, and exchange and repeat the process until this CL register is 0. Same procedure for largest number, and here if the number is small, we have to exchange. Here the number is large, if the number is large, we have to exchange. Here if the number is small, we have to exchange, okay. And sorting in ascending and descending order, and here we can see same algorithm, okay. Load the array count in two registers, C1 and C2, get the first two numbers and compare the numbers and exchange. If the two numbers if necessary, we have to arrange the two numbers in ascending order, okay. If, after getting every numbers, we have to decrement the C2 count and get the third number, okay. Until the C1 and C2 count registers are 0, we have to repeat the process. And for programming, we have, when we want to see the smallest data, we have to first move the address of 11002 source index register and 12002 destination index register, and we are getting the array numbers, okay. Number of inputs we are giving in the source index count as CL register and increment the source index value, and we have to get the next value to accumulator, and we have to decrement this count, okay. Decrement the number of total number of values in source index array, okay. Then after getting and incrementing, we have to increment source index value and we have to move that value to BL. Already we are having one value in AL and we have another value in BL, okay, register, and we have to compare this two. If there is a carry, then it will move to loop 2. This loop 2 carries, we have to decrement CL and jump on no 0. If it is not 0, if the CL is not 0, we have to compare it again, okay. Anyway, else we have to move, if it is not carry present, then move BL to AL, okay. And in this way we are getting the smallest value again and again. And after completing everything, that comparing every CL value, we have to finish the program, okay. And here we have given the input of 4 numbers, that is 03, 09, 05, 02, and we have get the output as 02. If we have given only 3 inputs, this 03, 09 and 05, then we can get the output as 03, okay. Then for largest data, the same program we have to study, but here there is a jump on carry, but here we can see jump on no carry, okay. Here also jump on non-zero only, we have to move to loop 1. Here also jump on non-zero only, we have to move to the loop 1. Same program, only this only we have changed. There is jump on no carry and jump on carry. And we are going to see the program for ascending order. Here also we are just extending the address of source index to assigning source index value to address to 8500 and moving the total number of datas, and we have to decrement then source index value to CH, okay, that is higher order of C register. Then we have to decrement and increment the source index value. After we are incrementing, we have to compare the source index value of now which we taken and the accumulator register. If it is a carry, we have to exchange, okay. There will be no exchange. Here we have to exchange when there is a carry, no carry present. If it is carry, we have to move to the loop 3, okay. Then anyway smallest number will be taken here, and if next number is also very small, means it will move to the it will move with respect to the source index minus 1 value, okay. And finally we have to halt the program. Here inputs are 0, 1, 0, 5, 0, 3, and from ascending order we have got the output 0, 1, 0, 3, 0, 5. For descending order, same program is explained here, and here there is no carry. See, here there is jump on carry. This is only difference, and so we our program is need not to be memorized, and we can compare this program and we can easily execute in the 8086 microprocessor. In 8086 microprocessor, after explaining this program, I have run for the finding the smallest number program. And now we are going to use 8085 microprocessor for a conversion of hexadecimal to ASCII code, and also we have used the rotate instructions here, and for BCD to hexa also I have done the program. 8085 microprocessor kit is different with 8086 microprocessor because of only 8-bit microprocessor is 8085 and 16-bit microprocessor is 8086 microprocessor. We have to load the given data in A register, move the content of B to A, and make the upper nibble, okay. Now upper nibble of hexadecimal number in A register, lower nibble to call the subroutine program, store it in memory. Now we have to move B register value to A register, and we have to mask the lower nibble value, okay. Then we have to rotate. This is the main thing. We have to rotate the upper nibble to lower nibble to change into hexadecimal value, and we have to call subroutine program, and we have to store the memory. For BCD to hexadecimal, this is very small program only. Initialize the memory counter and load the most significant digit, okay, and multiply with by 10, okay, using the repeated addition value. Add the LSD, that is least significant digit to result obtained, okay. Then store the hexadecimal value. Now we can see the program for ASCII to hexadecimal value. First we have to load, okay, load the accumulator with that of the address 8200, and now we have to move this B accumulator value to B register. Then we have to AND, okay, we have to AND immediate, okay, ANI means AND immediate the accumulated data with that of 0F, okay. These are all the instructions we have already studied in 8085 processor, and immediate data with the accumulator, and we have to call the subroutine program to get ASCII code, okay. This subroutine program is written here at the bottom, okay. This is after this halt only we have written the subroutine program, and now we have to store the accumulated data to 8201, and we have to move the data at B to A register, okay, that is accumulator register. Again we have to AND, okay, AND immediate data, okay, ANDing means it is multiplying, okay, multiplying the data of F0. Then we have to rotate left through the carry, okay, left, okay, to the carry for 4 times, and because the ASCII code we are in need of conversion of ASCII code to hexadecimal code, okay. Therefore we have to rotate left through the carry, and we have to call the subroutine program to save, and we have to store the data, accumulate data to 8202, and we have to stop the program. This is a subroutine program from 811A address. I can explain the subroutine program, and here we have to complement the 0A, that is accumulate complement the A value, okay, complement immediate the accumulator value with 0A, and jump on carry. If it is carry, we have to add immediate 30 value to it, else we have to, if there is no carry, that is we can add immediate 07 value to the accumulate data, and we have to return to the main program, okay. And this way we have to convert ASCII to hexa. Now we are going to see the BCD to hexa value. BCD, we very well know that there will be 00 to 09 values only, and if you want to write 10, we have to split 1 and 0 separately. For 1 we have to write 0001, and for 0 we have to write the data as 0000, okay. Now we can enter into the program that we have to load the address of 8150 to H register, HL register pair, and we have to move the memory, okay, that memory value which is stored in the 8150 to accumulator, and add the accumulator value. Then this most significant digit value we have to move, we have to add with the accumulator value and move it to the B register. Then we have to add again and again, okay, because we have to add 10 digits, okay. As we have seen in the algorithm, we have to multiply the most significant digit by 10, okay. Therefore only we are multiplying again and again, and add accumulator content with B register. Then increment the memory, then adding this accumulator to memory value, then increment the memory. We have to stop the program after moving this accumulator value to memory, okay. By using this halt function we can stop the program. Thank you.